Welcome, enthusiasts. In today's video, we're embarking on a journey that traces the roots of hydroponics back to ancient civilizations. From the legendary hanging gardens of Babylon to the ingenious floating gardens of the Aztecs, we'll explore how early farmers cultivated lush greenery without soil, using innovative methods that laid the foundation for modern hydroponics. But that's not all. We'll also explore the modern advancements that have made hydroponics a critical technology for sustainable agriculture today. From deep water culture to aeroponics, we'll break down the most popular hydroponic systems and how they can revolutionize your cannabis cultivation. Whether you're an experienced enthusiast or just starting out, this video is packed with insights and tips to help you harness the power of hydroponics. But before we begin, don't forget to like, subscribe, and hit the bell icon to stay updated with our latest videos. Also, please remember that this is an educational video and therefore all information provided is for informational purposes only. Thank you. And now let's begin. In the ever-evolving world of cannabis, one cultivation method that stands as a beacon of innovation is hydroponics. To understand this form of growing, we must first delve into the annals of history, tracing its roots through the ages as humanity's quest for sustainable agriculture and innovative cultivation techniques. Our story begins in ancient civilizations, where early farmers experimented with hydroponic principles without fully grasping their scientific underpinnings. The Hanging Gardens of Babylon, celebrated as one of the 7 wonders of the ancient world, are a legendary example of early hydroponic gardening. Built around 600 BCE by King Nebuchadnezzar II, the gardens consisted of tiered structures adorned with cascading plants. Necessitating an advanced irrigation system, a chain pump or a similar mechanism was used to lift water from the Euphrates River to the various levels of the gardens. This water was then distributed through a network of channels, ensuring that plants at all levels received adequate moisture. The growing mediums might have included materials like gravel or sand, supporting plant roots and allowing efficient water drainage and aeration, much like modern hydroponic systems. On the other side of the world, the Aztecs developed a sophisticated agricultural technique known as Chinampas. These floating gardens were constructed in the shallow lakes of the Valley of Mexico, particularly around Lake Texcoco. Chinampas were rectangular plots built on the lake beds, created by layering mud, lake sediment, and decaying vegetation. This method produced a fertile and nutrient-rich environment for plant growth. Separated by narrow canals, the Chinampas allowed easy access to water, with the lake's moisture rising through the porous layers of soil and organic matter, ensuring a continuous supply of water and nutrients to the crops. Both the Hanging Gardens of Babylon and the Aztec Chinampas demonstrate the ingenuity of ancient civilizations in developing hydroponic systems to grow plants without conventional soil. Fast forward to the 17th century, and the concept of hydroponics began to take shape with the pioneering work of Sir Francis Bacon. In his 1627 book Sylva Sylvarum, Bacon explored various aspects of botany and plant growth. One of the key observations he made was that plants do not necessarily need soil to grow. Instead, they require specific nutrients that can be absorbed through their roots. Bacon's work suggested that plants could be sustained with water containing these essential nutrients, which is the basic principle behind hydroponics. Bacon's ideas did not immediately revolutionize agriculture, but they planted the seeds for future exploration. In the 19th century, German botanist Julius von Sachs made significant contributions to the field of plant physiology, particularly in understanding plant nutrition and hydroponics. Among his most notable achievements were his innovative water culture experiments. In these experiments, Sachs identified the essential nutrients crucial for plant growth: nitrogen, phosphorus, potassium, calcium, magnesium, and sulfur. He proved that these nutrients, when provided in a soluble form, could be effectively absorbed by plant roots, underscoring their vital role in plant development. His research proved to the scientific community that plants can grow in nutrient solutions without using soil, demonstrating that plants could thrive on water and dissolved minerals alone. This groundbreaking method, now known as hydroponics, revolutionized agricultural practices. Moving forward to the 20th century, There was a surge of interest in hydroponics, mostly driven by advancements in technology and a growing awareness of the need for sustainable agriculture. Scientists from around the world started making grand discoveries that would continue to propel the industry into the future. One of these interested scientists was Dennis Hoagland. Starting in the early 1900s, Hoagland's research laid the groundwork for understanding how plants absorb nutrients and the essential elements required for their growth. One of his most significant contributions to this field is what is known as the Hoagland solution. Dennis created a nutrient solution that provides all the essential minerals plants need to grow. This product is still widely used in research and commercial hydroponic systems. The original formulation and its various modifications have allowed scientists and growers to cultivate plants in a controlled environment, making it easier to study plant physiology and improve agricultural practices. His work on nutrient solutions and plant nutrition has not only advanced the field of botany, but also provided tools for improving food production and sustainability. Hydroponics, as a result of his foundational work, is now a critical technology in modern agriculture, contributing to the development of vertical farms, greenhouses, and other innovative farming techniques. In the 1950s, the modern drip system was created by Simcha Blass. Blass's interest in efficient water use began during his work as a water engineer in Israel, a country with arid conditions where water conservation is critical. Blass observed a tree growing larger than others around it despite having no visible source of extra water. Upon investigation, he discovered that a leaking pipe nearby was providing a slow, steady trickle of water directly to the tree's roots. This observation led to the idea of delivering water directly to where it is needed most. Based on his research, he created a system that used a network of plastic tubes to deliver water directly to the base of plants through small emitters or drippers, which released water slowly and steadily. From this experiment, he found that by delivering water directly to the plant roots, there was a minimizing effect for water evaporation and runoff. Furthermore, and perhaps more importantly, fertilizers and other nutrients can be delivered through the irrigation system, ensuring they reach the plant roots efficiently. Moving forward to the 1960s, Dr. Alan Cooper, a scientist at the Glasshouse Crops Research Institute in Littlehampton, England, developed the nutrient film technique, NFT. This method became a major milestone in the field of hydroponics. The NFT involves a thin film of nutrient-rich water flowing continuously over the roots of plants that are supported in a sloped, watertight channel. His research showed that this ensures that roots have ample access to oxygen while still being able to absorb the necessary nutrients from the flowing water. Additionally, the recirculating system minimizes water and nutrient wastage, making it more efficient and sustainable than traditional soil-based cultivation. These benefits offer improved growth rates due to the optimal balance of water, nutrients, and oxygen delivered directly to the roots. NFT became popular for growing various crops, particularly leafy greens and herbs, and remains a widely used method in both commercial and home hydroponic systems. In the 1970s, cannabis growers finally began experimenting with various innovative cultivation techniques, including the use of hydroponics and volcanic rock as growing media. These methods provided growers with more control over the growing environment, leading to improved yields and potency. The hydroponic approach facilitated the move to indoor cultivation, allowing growers to cultivate cannabis year-round in controlled environments. This shift was particularly important in regions where outdoor growing was risky or infeasible due to weather constraints. Similarly, experimentation showed that volcanic rock offered ample benefits as a growing medium for cannabis. For example, volcanic rock provides excellent aeration, ensuring that plant roots receive ample oxygen, which is crucial for healthy growth. Similarly, the porous nature of volcanic rock allows for excellent drainage, preventing waterlogging and root rot. Finally, volcanic rock is chemically inert, meaning it does not interact with the nutrient solution, ensuring that plants receive a consistent supply of nutrients. Now that we understand the history and science of hydroponics, let's discuss some of the more popular hydroponic systems: deep water culture, nutrient film technique, ebb and flow, aeroponics, and drip systems. Deep water culture, DWC, is a hydroponic method where plant roots are submerged in a nutrient-rich, oxygenated water solution. This system is known for its simplicity and effectiveness, providing an ideal environment for fast-growing plants like cannabis. The primary components of a DWC system include a reservoir, an air pump with air stones, net pots, and a lid or support structure. The reservoir is a container filled with a nutrient solution where plant roots are submerged. An air pump connected to air stones placed in the reservoir oxygenates the nutrient solution, ensuring the roots receive adequate oxygen. Net pots, which have holes to hold the plants, allow roots to grow through and into the nutrient solution. A cover or support structure holds the net pots above the reservoir. So how does it all work? Plants are placed in net pots filled with a growing medium like clay pellets or rock wool. These net pots are then placed in holes on the lid of the reservoir, allowing the roots to hang down into the nutrients. The reservoir is filled with a solution that provides all the essential nutrients required for plant growth. This process must be monitored and adjusted regularly to maintain the correct pH and nutrient levels. An air pump connected to air stones oxygenates the nutrient solution by producing bubbles, ensuring that the roots have access to sufficient oxygen, preventing root rot, and promoting healthy growth. Since the roots are constantly submerged in the nutrient solution, the plants have continuous access to water and nutrients. DWC systems offer several advantages, including rapid plant growth due to the constant availability of nutrients and oxygen, simplicity and low maintenance compared to other hydroponic systems, and cost-effectiveness as fewer components and less equipment are needed. The closed-loop system also minimizes water and nutrient waste, making it an environmentally friendly option. DWC systems thrive in environments where temperature, humidity, and light can be consistently controlled. They are ideal for fast-growing crops like lettuce, herbs, and cannabis, where rapid growth and high yields are desired. DWC systems are also suitable for small to medium-scale grow operations due to their simplicity and cost-effectiveness. While DWC systems are excellent for environments with consistent control over temperature, humidity, and light, and are perfect for growing fast-maturing crops, the nutrient film technique, NFT, offers an equally efficient yet distinct approach. In NFT systems, a thin film of nutrient-rich water flows continuously over the plant roots, providing them with both nutrients and ample oxygen. This method is particularly advantageous for those looking to maximize growth rates and yield in a controlled environment, even with limited space. For growers seeking quick results, especially in cannabis cultivation, NFT systems provide a scalable and highly effective alternative to DWC, ensuring optimal use of resources and accelerated plant development. In an NFT system, the main components include growing channels, a nutrient reservoir, a water pump, and a drainage system. The growing channels, where the plants are placed, have a slight slope to allow the nutrient solution to flow through them. The nutrient reservoir holds the nutrient solution, and the water pump circulates this solution from the reservoir to the growing channels. The drainage system allows the nutrient solution to flow back into the reservoir after passing through the growing channels. The process begins with placing the plants in net pots or directly in the growing channels, with roots extending into the channels while the plant itself is supported above. The water pump continuously moves the nutrient solution from the reservoir to the high end of the growing channels. The solution flows over the roots of the plants in a thin film, providing them with essential nutrients. Gravity helps the nutrient solution flow from the high end to the low end due to the slight slope of the channels, ensuring a continuous and even distribution of nutrients to all plants. As the nutrient solution flows over the roots in a thin film, it ensures that the roots are not submerged in water, allowing them to be exposed to ample oxygen. This oxygenation is crucial for healthy root development and overall plant growth. After flowing through the channels, the nutrient solution drains back into the reservoir, where it is recirculated by the pump. This closed-loop system ensures minimal waste of water and nutrients. NFT systems offer several advantages, such as efficient use of nutrients and water, high oxygen levels for roots, scalability, and reduced risk of root diseases. However, there are also some disadvantages, including the risk of system failure due to interruptions in nutrient flow and the need for precise management of nutrient levels, pH, and flow rates. While NFT systems excel in environments with stable conditions and are geared toward experienced growers seeking to optimize growth and yields through precise management, ebb and flow systems provide a more user-friendly alternative. This hydroponic method, also known as flood and drain, periodically immerses the roots in a nutrient-rich solution, allowing for balanced nutrient uptake and oxygen exposure, which is particularly beneficial for cannabis cultivation. The primary components of an ebb and flow system include a grow tray, a reservoir, a water pump, a drainage system, and a timer. The grow tray is a container where plants are placed, typically filled with a growing medium like clay pellets, rock wool, or perlite. The reservoir holds the nutrient solution, and the water pump moves this solution from the reservoir to the grow tray. A drainage system allows the nutrient solution to drain back into the reservoir after flooding the grow tray. A timer controls the water pump, regulating the flood and drain cycles. So how does the ebb and flow method work? Plants are placed in the grow tray with their roots supported by the growing medium. The tray is positioned above the nutrient reservoir. At set intervals, the timer activates the water pump, which moves the nutrient solution from the reservoir into the grow tray. The tray is flooded with the solution, submerging the roots and providing them with nutrients. During the flood cycle, the roots absorb the nutrient solution, and the growing medium retains some of the solution, ensuring that the roots remain moist during the drain cycle. After a set period, the timer turns off the water pump, allowing the nutrient solution to drain back into the reservoir. This exposes the roots to air, providing them with oxygen. The flood and drain cycles are repeated at regular intervals, ensuring that the plants receive a balanced supply of nutrients and oxygen. Ebb and flow systems offer several advantages. The system recirculates the nutrient solution, minimizing waste and ensuring efficient use of water and nutrients. It is flexible and scalable, making it suitable for different grow operations, from small home setups to large commercial farms. The alternating flood and drain cycles ensure that roots receive ample oxygen, promoting healthy growth and reducing the risk of root rot. Additionally, the system is relatively simple and inexpensive to set up and maintain. Ebb and flow systems work well in a variety of growing environments, making them suitable for both indoor and greenhouse setups. They are ideal for a wide range of plants, including leafy greens, herbs, and flowering plants like cannabis. The simplicity and efficiency of ebb and flow systems make them a good choice for both novice and experienced growers. For those seeking an even more advanced and efficient approach, Hydroponics offers a unique method of cultivation. In this technique, plant roots are suspended in the air and periodically misted with a nutrient-rich solution, ensuring an optimal supply of oxygen and nutrients that fosters accelerated and robust plant growth. The primary components of an aeroponic system include a growth chamber, misting system, nutrient reservoir, pump, timer, and support structure. The growth chamber is an enclosed space where plant roots are suspended in the air, helping to maintain humidity and preventing light from reaching the roots. The misting system consists of nozzles that spray the nutrient solution onto the roots at regular intervals, connected to a nutrient reservoir. A pump moves the nutrient solution from the reservoir to the mist nozzles. The timer controls the misting intervals, ensuring the roots receive regular misting without being oversaturated. The support structure holds the plants above the growth chamber, allowing roots to hang freely. In an aeroponic system, plants are placed in small holders or collars on the support structure, with their roots hanging down into the growth chamber. The timer activates the pump, sending the nutrient solution from the reservoir through the mist nozzles. The roots absorb the nutrient mist, providing the plants with all necessary nutrients for growth. The fine mist ensures that the roots are well aerated and do not become waterlogged. Between misting cycles, the roots are exposed to air, providing ample oxygen, which promotes healthy root development and overall plant growth. The misting and air exposure cycles continue at regular intervals, ensuring that the plants receive a consistent supply of nutrients and oxygen. Aeroponics offers several advantages. The high oxygen levels and efficient nutrient delivery promote faster plant growth compared to traditional soil and other hydroponic methods. They use less water and nutrients compared to other methods because the nutrient mist is directly absorbed by the roots with minimal waste. The constant exposure to oxygen and nutrients leads to a healthier and more robust root system, which can result in higher yields. Additionally, aeroponic systems can be designed vertically, making them ideal for space-constrained environments. Aeroponic systems thrive in environments where temperature, humidity, and light can be consistently controlled. They are ideal for high-value crops like cannabis, where rapid growth and high yields can justify the higher setup and maintenance costs. Additionally, aeroponics is used in research and development due to the precise control over nutrient delivery and root environment, allowing for experimentation and optimization. Drip hydroponics is a versatile and widely used method of growing plants where a nutrient-rich solution is delivered directly to the base of each plant through a network of tubing and emitters. This method provides precise control over nutrient and water delivery, promoting healthy plant growth, and is best used in controlled environments with stable temperature and humidity, and it is suitable for both beginners and experienced growers. The primary components of a drip hydroponic system include grow trays or pots, a nutrient reservoir, a water pump, drip lines and emitters, a timer, and a drainage system. Grow trays or pots are containers where plants are placed, typically filled with a growing medium like rock wool, perlite, or clay pellets. A water pump moves the nutrient solution from the reservoir to the drip emitters. Drip lines and emitters are a network of tubing and small emitters that deliver the nutrient solution directly to the base of each plant. A timer controls the water pump, regulating the frequency and duration of nutrient delivery. The drainage system collects excess nutrient solution and returns it to the reservoir for recirculation. Plants are placed in the grow tray or individual pots filled with a growing medium. The grow tray or pots are positioned above the nutrient reservoir. At set intervals, the timer activates the water pump, which moves the nutrient solution from the reservoir through the drip lines and emitters. The emitters deliver a controlled amount of nutrient solution directly to the base of each plant. The growing medium absorbs the nutrient solution, providing the plants with all necessary nutrients for growth. The medium retains moisture and nutrients, ensuring that the roots have constant access to the solution. Excess nutrient solution drains from the grow tray or pots and is collected by the drainage system. This solution is returned to the reservoir for recirculation, minimizing waste. The timer regulates the frequency and duration of the nutrient delivery, ensuring that plants receive a consistent supply of nutrients and water. Drip hydroponic systems offer several advantages. They allow for precise control over nutrient and water delivery, ensuring that each plant receives the optimal amount. The recirculation of the nutrient solution minimizes waste and ensures efficient use of water and nutrients. Drip systems can be easily scaled and customized to suit different grow operations, from small home setups to large commercial farms. Additionally, the use of a growing medium instead of soil reduces the risk of soil-borne diseases and pests. Drip systems are ideal for controlled environments like greenhouses or indoor grow rooms where temperature, humidity, and light can be consistently managed. This system is suitable for a wide range of plants, including leafy greens, herbs, vegetables, and flowering plants like cannabis. The simplicity and versatility of drip systems make them a good choice for both novice and experienced growers. And there you have it, enthusiasts. We've taken a deep dive into the rich history and science of hydroponics, exploring how ancient civilizations like the Babylonians and the Aztecs laid the groundwork for this innovative method of plant cultivation. We've also journeyed through centuries of scientific discoveries that have propelled hydroponics to the forefront of modern agriculture. Today, hydroponics has evolved into a critical technology that supports sustainable agriculture, especially in cannabis cultivation. Whether it's the simplicity of deep water culture, the efficiency of the nutrient film technique, the versatility of ebb and flow, the innovation of aeroponics, or the precision of drip systems, hydroponics offers diverse methods to optimize plant growth and yield. So whether you're a seasoned grower or just starting your hydroponic journey, we hope this video has provided valuable insights and inspired you to explore the endless possibilities of this remarkable growing technique. Before we wrap up, don't forget to like, subscribe, and hit that bell icon to stay updated with our latest videos. And if you found this video helpful, please like, subscribe, and share it with your friends. We have plenty more educational content coming your way, designed to help you become a more knowledgeable and successful enthusiast. Thank you for joining us on this journey through the fascinating world of hydroponics. Until next time, stay curious.